Here we have a set of etches that we've developed for a 4mm scale of the Andrew Barclay from the 7mm one that you've seen me constructing. The methods are exactly the same as for the 7mm one, the only difference being obviously the size of the logo for 4mm scale and the thickness of the metal. Obviously there's no point in having the thickness of the metal the same thickness as the 7mm one, because with smaller components like this it'd be much harder to bend and fold the various parts that you needed. This particular one is done on 12 thou nickel silver as opposed to the 18 thou nickel silver or brass that the original 7mm one was on. All the measurements for this were taken from the 7mm one, and so we've basically just transferred them into this scale. So theoretically they should all be right. If they fit for the 7mm one, then they should fit for this one. But as is usual with these sort of things, well laid plans etc. never work out exactly how you want, and there are one or two modifications that we've got to do to this initial test etch in order to make it available for sale to the general public, as it were. Just few mistakes, simple measurement errors, few holes missing out of the various places. Anyway, you have the main components here, the foot plates, buffer beams, the tank sides, frames for the thing. Then there are two sets of spacers, one for double O and one for EM, which is useful in 4mm scale, coupling rods, brakes which have to be laminated together, various other components. The boiler comes flat, although when you get your kit it will probably be pre-rolled for you. Unfortunately, because I model mainly in 7mm, my rollers are actually too big to do with this, but the simplest thing to do is to find yourself a bit of flat bar or a bit of dowel or broom handle or something like that, and I'll show you how to do that now. Here we have one of the formers for the boiler, which goes inside to help retain its shape, etc., and the front of the smoke box effectively. So this is the sort of diameter of tube that you ideally need to roll this boiler if you haven't got any actual boiler rollers. So I've cleaned up the thing. I've got a small bit of tube here that we found because I haven't found anything suitable. But basically, if you just put that in there and just bend it with your fingers, just bend it round like that, make a start on it, just gently ease it round with your fingers. You can heat it up and then quench it to make the metal softer, and that'll work equally as well, but literally just doing it with your fingers like that will be sufficient. It'll take a little bit of time to get it done, but you just gently roll around, forming the shape. As you can see from there, it's a little bit but again you can just shape that out with your fingers and roll it round like that. When you've rolled it to the complete way round, then you can obviously join the two parts together and solder them up and put the formers inside. There are some more formers here which go in the half round parts. This part is cut out so that when the boiler goes into the loco, as in that one, you can see the gap there. That's where the motor will sit inside there, giving you plenty of space inside to get a fairly large motor in there. Got one here that is complete with the smoke box on. There's no fittings on it yet, but the smoke box has been formed around it in exactly the same way, just tweaking around with your fingers. The smoke box door is added. This will become a casting in the kit, so you won't have to worry about making that up like I have with this one. The other thing is that the smoke box on most prototypes usually is of a bigger diameter than the boiler itself. what you'll find sometimes is that when you put the smoke box front on, is that it'll be a little bit higher than the thickness of that metal. This slight step in the smoke box here, there's on a lot of prototype smoke boxes were of a slightly bigger diameter than the boiler or the boiler cladding, and so you can see here that there's a slight step. This particular model kit will supply an extra wrapper inside to build up that thickness, so that you're not ending up with a gap, or with the smoke box being one diameter at one end and then trying to fit it to the boiler the other end, ending up with a slope and it not being square and parallel. If there isn't sufficient parts in whichever kit you buy to do this sort of thing, and there is a gap there, then the simple thing is just to cut out a bit of scrap metal, the width of that or slightly smaller, and just solder that round the boiler before you solder the smoke box wrapper around it. But apart from that, everything else is pretty simple to put together. On the underneath of this one, this particular prototype, the captured nut for fixing the chassis to the body is actually fitted to the underneath of this smoke box, and although on the body there is a hole here for the thing, it's no good fitting the nut to there, because you could fit it to there, but then you'd have to open out that hole in order for it to fit over the top of the nut. So it's easier to fit the nut in there. It also has the added thing is that when you put the boiler in, that you could actually make the boiler removable along with the body. In some prototypes where you need to line the boiler or you need to get to it to paint it and things like that, that can be an advantage, having this as a separate thing. The only difference is that you need to come up with some sort of method of fixing it to the back of the spectacle plate. Otherwise, when you fit this particular one in here, if it's not fixed at the bottom, it doesn't pull it up sufficiently enough to keep that level, as it were. That boiler needs to go up a little bit. So I prefer to solder this particular one, as most of these engines are plain black anyway. As you can see on this particular prototype, there are a few rivets to punch out. They're marks with half-etched dimples in them. Now, I can't emphasise enough really that if you're going to get into modelling, the best thing to use to punch these out is a proper riveting tool. My riveting tool I got from Model Metalsmith. I'll start that again. 3, 2, 1. As you can see on this particular model, there are a few rivets to etch out. Not many, but there are a few. These are represented by a half-etched dimple in the positions where they need punching out. I can't emphasise enough, if you're going to get into modelling, one tool that is not essential but is a very useful tool if you're going to get into modelling, especially if the kit comes with a lot of rivets that aren't already etched in, is to buy yourself a riveting tool. The one I have, I got from Metalsmith. It comes with both anvil and point for 4mm and 7mm. Obviously I use the 7mm one a lot more than I do the 4mm one, but for the benefit of this particular kit now, I've put the 4mm anvil into the tool, and I'll show you. You could use, I mean, something as simple as this thing that I'm pointing out. A sharp point like that is, if you use that on a hard surface, it will punch a rivet out. There you can see I've used this point to actually push out 3 rivets there. There's rivets go all the way along this particular plate, but as you can see, I punched out 3 rivets there, and it's a reasonably good representation of what you need. So you don't need to go to the expense of an expensive riveting tool. As I say, this point will do quite well. The only disadvantage with doing it this way is that when you're on very thin metal, and or in the case of these parts here, where there isn't that much width of metal, is that sometimes when you push down on these you can end up distorting the metal, and it can bend. So as you do them, you need to keep straightening them out while you do them. Here we have the frames, the sides of the frames, and a spacer, in this case a double O spacer. These have got a half etch line in them, and it's just a case of folding them up so that they're square. Check that with a square if you want to. And then on the chassis you'll find various slots and positions for these spacers, and these just go into the sides of the slots like so, and then you can tack solder the frame spacers inside the frames in exactly the same way as you would do for any scale of model, as I've shown you with the 7mm one. These frame spacers are designed, they're all the same size, so you can't mix them up. They all fit into either a slot there or a slot there, etc. You might have to leave one of them out in the space where you're going to have your motor, because you don't want the motor fouled by a frame spacer, which will need cutting out, and it's a lot more difficult to cut them out afterwards. So the best thing to do is just decide where you're going to stick your motor, which axle you're going to stick it on, and how much of the frame you need to cut away. You might not necessarily have to cut it all away, you might just have to cut some of it away. And then once the frame's done, the next thing to do before you start soldering the frame together is to get yourself the bearings. The bearings, which are quite small, they fit inside the holes in there. Two of these holes are elongated on this in order to give you some movement up and down, so they don't necessarily need soldering. If you want a rigid chassis, then you can solder it. And then you've got one hole, which is usually for the fixed hole, which is usually for the driving axle. That one doesn't need to move up and down. You can, an 060 like this just needs two of the axles to move up and down. You can make all three axles move up and down if you wanted to, but it's never been necessary as far as I'm concerned. You might need to ream the holes out a little bit with a small round file just to get the bearings to fit in place. You shouldn't need an awful lot of fettling. If it does need an awful lot of fettling, then there's something wrong with the kit, and I'd try and avoid it, because once you start going a little bit more than you actually need for a hole, then you can start to drift out, and you can start altering the wheelbase, and then you find your coupling rods won't fit, etc, etc. I'm sure that many of you 4mm modelers, if you're not already familiar with these particular type of wheels, you may have heard of them. These are Romford wheels, which are quite popular, and as popular in 4mm scale as Slaters are in 7mm scale. The fixing points in the centre of the axle is a threaded washer, thick washer, with two slots either side of it. Now, I understand that Romfords do sell a specialist tool to be able to do these, but what I did was I modified an old screwdriver. Literally, it's just a screwdriver. You can get one from the pound shop or wherever it is. It doesn't have to be a particularly good quality one, and I've literally just got the grinder and or a file, and just filed a groove out it to give it two prongs, and then the prongs then fit inside there, and you can then tighten the wheel up. Don't over tighten them. I did over tighten a couple of them, and they ended up falling off, and I ended up having to find a couple of 10BA nuts and using those to fix it on with instead. The other thing is then the Romford wheels come with these crank pins which screw into the hole here. I found them a little bit tight, and so as you can't get much grip on them, you need to be careful to make sure that you don't damage the ends of the bearings that have to take the coupling rods. But once they're in, I also found that they started to wind themselves out as well on the chassis that I did. So they may need, once they're in there, they can stay in there once they're in there. So you could put them in with a spot of super glue just to keep them in place. but make sure that they're well seated before you do that. So here we have a completed chassis. We have the coupling rods in place. Now the coupling rods are being fixed. I don't know whether you can see this particularly well. Have been fixed with a little bit of insulation off some wiring over the end of the crank pin. You can see it there. It's just a little bit. I was told by a friend who models in Paul Mill quite regularly that he uses the refills out of the Bic Biro. I didn't have a Bic Biro to hand, and the Barclay's free pens that I had, the refills in those were too big and they didn't work. So I cut up a bit of insulation off the end of a bit of wire, and that works just as well. He told me to do this because I was simply asking. There's an actual brass washer that fits over the end of these crank pins for these particular wheels, but the only way to fix it is either to glue it, which I wouldn't recommend because the glue's going to go into the bearing and stop the crank pins from going round. You'd have to be very, very careful how you glued it on, and the other alternative is to solder it. The only way I can see of doing that is to put a bit of paper over the end, poke the paper over the end of the rod, then put the bearing on and then solder it. That would stop the solder from running into the coupling rods and seizing everything up. This small Machima motor, which is a 1424, 14 being its diameter, 24 being its length, I think is probably about the biggest motor that I'm going to be able to fit in this particular chassis. It doesn't quite fit inside the frames for a 00. It sits on the top, so it may be that you'd be able to modify it slightly in order to be able to get that to sit in there. Once the gear's on, it's more than likely going to have to go at an angle like that, and which may require cutting out a little bit of the frame there in order to get it to sit in. These are a bit trial and error, these sort of things. I'm sure that there are motors and gearboxes that you could buy that will fit straight in, and certainly with the EM version this wouldn't be a problem because the frames will be slightly wider on the EM version, so it should slot in without any problem. So again, this is all compromises with regards to getting things to work properly in this particular scale. I was saying about the slots in the frames in order to allow compensation. You can see there that those two wheels will move independently up and down to give you some level of compensation. This will improve traction and pulling power of the loco without adding any additional weight, and also if the track's a bit uneven it'll obviously make it derail a lot less. The bearings are not fixed at all, they're just on the ends of the axles, so you don't need to fix the bearings. They will survive. If there's enough clearance between the axle and the bearing, the axle will rotate without the bearing rotating, but it doesn't really matter if the bearing rotates anyway. It would take an awful long time before you wore it out and wore a hole in the frames, because the coupling rods will keep the thing more or less in the plane that it's supposed to be anyway. This chassis has had all the brake rigging etc. added, and the brakes. The brakes are a fair distance away from the wheels in the position that they are, but again this makes removal of the wheels a lot easier and also cuts out the possibility of short circuiting when you wire it up. But apart from that, the assembly of the frames is exactly the same no matter what scale you're doing. It's just a little bit finer in this scale.